Mr. Strauss's Chemistry Corner was filmed before a live audience. No laugh track was used at any moment during this videotaping, and no animals were hurt. Episode 7, London Dispersion Force Awakens.
Oh my God.
So, we've gone through single displacement and double displacement. Oh, I'm sorry, to my Polish friends again, cześć. And to our Polish viewers, guten Morgen. Because it should be about 7 o'clock right now. So we've done single displacement, double displacement, synthesis reactions.
We haven't done synthesis.
Are pretty simple. Synthesis means to combine, okay? So all you do is take whatever they give you and you plug it together. So suppose I've got, let's try to do something simple here. Okay, this is probably too simple, but let's do it anyhow. Sodium plus chlorine, okay? So the two things are going to combine into one thing. And in the beginning, it's going to be kind of difficult, Hallie, to predict what that single product will be, okay? But after you've done a few million of these, well, 1,000 of these, that's my goal, you guys will be good at predicting the product. So what do you think is going to happen if you combine sodium and chlorine? You're going to get sodium chloride. A synthesis always has one product. Okay, you're going to get one product out. And yes, you guessed correctly, Malgosha, that it's going to be sodium with chlorine. So, would you prefer I use your nickname Gosha? So, write the charges and then balance it. So, one goes here, one goes there. I don't just, when I combine it here, I don't just put the two there. Okay? You've got to rewrite the charges and balance it. Once you have the formula balanced, then you balance the whole equation, Pietro. Okay? So, 2 here. Right, Pietro? 2 here, 2 there. Gives me 2 sodiums, 2 sodiums. All right? Let's see, another synthesis reaction.
What is this table sheet?
I think of another good one. Sure. Nitrogen plus hydrogen. Now you may not know what that produces. But again, through doing a few thousand of these, you'll get a better idea. So the nitrogen and the hydrogen will combine to form ammonia. Now, that's the formula for ammonia. You don't need to write the charges and balance it. That usually happens with nonmetal to nonmetal. Okay? And again, there's really no way you're going to be able to know for sure that that's the product unless somebody tells you. So how did I know this? Somebody told me when I was your age. Now I'm telling you. That's how this information gets passed on from generation to generation. So 3 here, I've got 2 there. I got 2 nitrogens here, I'll put a 2 there. And now I'm going to put a 3 there to balance the hydrogens. Is that good, VJ? Yeah? All right, just checking. All right, number 4. Combustion. We did organic combustion, and I'll just review it with you quickly, and then we'll do inorganic combustion. And sometimes reactions can fall into both categories. So combustion is when you react with what? Oxygen. So anytime you react with oxygen, it's combustion. So we've got type 1, which was organic. So organic combustion is when you've got basically carbon, hydrogen, or oxygen. The official, I shouldn't say official, it used to be that the definition of organic was molecules that can only be created by living things. So for example, DNA, blood, saliva, urine, proteins, sugars. Those were only things that could be made by living things, so they called them organic. Versus non-living things like sodium chloride, that could be made by the ocean. So that was inorganic. But around the 1700s, Brandt, I forget his first name, he synthesized urine. He created synthetic urine. And so they realized that you could make organic molecules from inorganic ones. And so they basically changed the definition. Organic now basically means carbon-based molecules. Okay. Wait, no, Brandt didn't synthesize urine. That's wrong. Brandt tried to discover gold from distilling urine and isolated phosphorus. Sorry about that. Brandt did not make urine. I forgot who it was. So, let's see here. So, organic combustion, we did. How about good old? Sure, why not? Propane. Anybody got liquid propane at home to heat their house? No? Okay. So propane is C3H8. React with oxygen. What are the two products you always get out with organic combustion? CO2 and water, right? So we don't have to balance these formulas because they're already balanced for us. And all we have to do, Agnieszka, is balance it all out. Right? So C3, you can send hate mail to C3. 3 goes there. I don't want to give out my real address. So. Yeah, C3, 3 carbons, H8, so I put a 4 there to give me 8 hydrogens. 3 times 2 is 6, plus 4 oxygens is 10, so I put a 5 there, so it's balanced. Type 2 is inorganic, and really it's a synthesis reaction. So this could be synthesis or this could be combustion. For example, magnesium, and we'll do this in the lab, it's pretty cool. You can burn magnesium metal. If you get it hot enough, the magnesium will react with oxygen in the air, it burns super bright, and you just combine the 2 elements. So magnesium is a +2, oxygen's a -2. It's already balanced. So I erase the charges. And then I balance the whole equation. So you got a 2 there, put a 2 there, 2 there, it's balanced. Okay? So all you do is just combine the 2. So this could be a synthesis, right? Because I'm ending up with one product, or you could call this combustion. So what will we get out? Iron's a 3+, or iron can be a 2+. So what should we pick, Lukash? 3 or 2?
2.
2?
2.
Okay, 2 it is. So, 1, 2, 3, 4, 5, 6,
Right.
7, 8, 10, 11.
Is that like 1 through 10 or something?
I hope so, otherwise I just insulted someone really bad. So, +2, -2, that's balanced. You can pick either charge. So then we're gonna need a 2 there or a 2 there. All right, the last category is probably the most difficult, and that's decomposition. When you take your quizzes and your test, you're gonna wanna use Appendix E to help you with it, because you're not gonna be able to predict the products offhand. I've done it for a long time, so I can, but you won't be able to. So decomposition, there are 7 major types. We're gonna learn all of them, yep, but I'm going to refer to your appendix. E. This is the second page of appendix E. What I'll do is I'll just give you another example in addition to the one that they're giving you. Okay, so type 1 says you're going to heat a metallic carbonate. Where are the metals on the periodic table? Find the staircase, right? So everything to the left is a metal. So if it's a metallic carbonate, when you heat it, it'll give you the metal oxide plus carbon dioxide. Okay? The triangle means heat. Okay? So let me give you another example. So if we have sodium carbonate, is that a metallic carbonate? Yes. What will I get out? Well, is there anything else for it to react with? Is there another thing it's reacting with here?
No.
No. That's, the first clue is decomposition, because there'll only be one thing on that side. There'll only be one element, or one compound. So there's nothing else for it to react with. It must be decomposing. It must be breaking down. The question is just, what does it break down into? Well, it's going to break down into the metal oxide, balance it, and carbon dioxide. Those will be the 2 products. And like I said, there's no way you would have guessed that unless I would have told you. 2 sodiums, 2 sodiums. 1 carbon, 3 oxygens, it's balanced. If you heat a metallic hydroxide, it will decompose into the metal oxide and water. So if you heat a hydroxide, it will turn into metal oxide and water. So let's see, what's a nice, sure, why not? triangle means heat. So what we end up here is, they said metallic oxide, so write the charges, balance it, it's balanced. And then what's our other product, Giselle?
What?
What's the other product we get out? Oda, Vasa, O.
Okay.
Right? If you don't remember, just look at type 2 on appendix C. Then we balance, one magnesium, 2 hydrogens, 2 hydrogens, 2 oxygens, 2 oxygens. Type 3, metallic chlorate, if they're heated, decompose into metallic chlorides and oxygen. This is the one we did our gummy bear demo with. So if you heat a metallic chlorate, you're going to get the metal chloride. So the metal chloride plus oxygen. So we'll need a 3 here to balance it. And again, on the left side, there's only one compound. That's how you know it's decomposition, because you only see one thing. Can I erase this?
Yeah.
Type 4, you got 3 more to go. If you look at appendix C, it says, what happens when you heat a metallic nitrate? If you heat a metal nitrate, you get the metal nitrate, you get the nitrite plus oxygen. So let's see here. If you heat, how about if you heat the nitrate, you get the metallic nitrite. Write the charges, balance it, I'll need a 2 there. And I will get oxygen. Erase the charges, and it's balanced, isn't it? Nice. Type 5. Acids. When you heat acids, they decompose into water. So if we take, and this gets tricky. Let's see. When you heat an acid, you get out water. So I recommend you write the water first. And then what's left? What didn't we use up? Sulfur. And how many oxygens didn't we use? 3. So it'll be SO3. So you just look at whatever you didn't use up, that's what's left over. So it should all be balanced, and it is. Type 6, oxides when they heat. And this is one way for getting pure metals. Suppose you take, this isn't the only way you can do it, but suppose you dig up aluminum oxide out of the ground. Most metals are not found in their pure form. Okay, only very few metals like gold, silver, copper, nickel, do you dig them up and they're in their pure form. A lot of other metals are combined with something else. If you heat it, you can get the metal by itself, and oxygen will be released. And then you can get the pure metal. So what are we going to need to balance this here? 2 there. I've got 3 oxygens here. I'll need a 3 there. That gives me 6. So then I'll have to put a 2 there. And now I've got 4 aluminum, so I got to go back and change that to a 4. Now, sometimes, and Appendix E gives an example of this, it won't give you the pure metal. It'll get close, but not quite. It's called incomplete decomposition. And the example they give you is lead. If you heat lead, you've got lead 4. If you heat it, it could give you lead 2 oxide plus oxygen. And then you balance it. If you want to get lead by itself, then you have to heat this, the lead 2 oxide, and really heat the heck out of it. And then you can get lead by itself. So this is called incomplete decomposition. That's complete decomposition. And then the last one, type 7, and then you've survived, is electricity. For some things, if you zap it with electricity, it'll break apart. And didn't I demo this for you this year already? Where we took water and we broke it apart with electricity. So if you run electricity through water, you will get out what? Hydrogen and oxygen. All it does is break it apart. If you zap electricity, it breaks it apart. However, what do we know about hydrogen? Diatomic. Oxygen, diatomic. So we'll need a 2 there and a 2 there. So let's do a couple examples and I'll give you some time to work. And again, in the beginning here, it's going to be tough, Tristan, and then after a while, you get okay at it. Right, Wukash? The front side's a little bit easier than the back side. And for homework, we're just gonna do the front side. So as you can see, now you're gonna have to predict the products. I've still written the reactants for you. And then on the back side, it gets harder because how did I write the reactants on the back side? As words, okay? Well, we won't do the back side for homework, Danny, just the front side, okay? And the number out front tells you the number of products. So when I look at number 3, there's a little 2 there. So that tells me there are going to be 2 products. And then I have to try to figure out which type it is. So when I see this, I see a single displacement. So I'm going to end up with hydrogen, which is diatomic, and zinc, which is a +2, chlorine's a -1. Put a 2 there. Erase my charges. 2 chlorines there, put a 2 there, and now the reaction is balanced. Anytime you see the word heat, it's going to be a decomposition. Plus, you can tell there's only one compound on the left side. So, decomposition, 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 decomposition.
Wait, how else can you tell?
The only way you can tell is if there's only one substance. So, like, that's it. There's nothing else for it to react with. All right. So I will put the answer key up front here, but I'll come around and help you guys. Use a pencil. And what do you do if you can't get the reaction to balance? Cry. No. Go back and check the formulas, because they're probably incorrect. Okay? So this is Mr. Strauss's Chemistry Corner signing off. Dobranoc, guten Sieben, and namaskarat.